Okay, here we have a third problem. Once again, I'm going to distribute. So this -2, I distribute to both sides. And so -2 times 3p is just -6p. -2 times 4 is -8, is greater than -12 minus 6p. Now I'm going to rewrite this other side. So I have -6p minus 8 is greater than -6p minus 12. Now, once again, if this were an equation, this would be clearly no solution, right? -6p minus 8 is equal to -6p minus 12. That's never going to be true. So that's just because we have the same variables and different constants, just no solution. Unfortunately, it's not an equation, so it's not quite as simple as that. So we have to kind of go down to ourselves and see, and let's kind of put it in terms of p plus our constant, right? So the way I would do this is I'm going to divide by -6, divide by, or so actually first, let's do this. Let's kind of add 8. So I have -6p is greater than, I don't know what that is, don't allow paste. -6p is greater than -6p minus 4, right? And then I'm just going to add 7p, and this is just going to make things a little bit easier. Add 7p, and the reason why I'm doing that to illustrate is I want to get p on this side. So I have p is greater than p minus 4. And you kind of want to get the variable to the point. Now ask yourself, is this true? If I put any number into p, right? So think about if I plug 5 is greater than 5 minus 4. Well, of course that's true. And if you can see for basically all values of p, this statement's going to be true. You could also take it to no p. You could cancel out all the p's. So I could do minus p, and I get 0 is greater than minus 4. And see how this is a true statement? This is a true statement. Therefore, it's going to be all real numbers. In this case, for every number I plug into p, this is going to be true. Where basically, if I plug in any number into p, it's always going to be bigger than itself minus 4. And then when I graph all real numbers, I just draw an arrow going on both sides because that shows it's all my numbers right here on the number line.